Welcome back to How Safe Is Our CyberSpace, the podcast where we expose the tactics and strategies that these malicious cyber threat actors uses to exploit us on a daily basis. My name is Chinedu Francis, your host, and today we'll be exploring the topic, how hackers exploit software vulnerabilities, with our main focus point on SSS, the ground cookie stealer. To help us break this down today, we have a special guest, Cyber Fortress, a penetration tester and a bug bounty expert from PentrySec. Let's dive in so you can enjoy the conversation. Welcome, Cyber Fortress, to How Safe Is Our CyberSpace.
Thank you for having me.
We'll go straight to the point. Cyber Fortress. How do vulnerabilities sneak into software development lifecycle from design to deployment?
All right. Before we go into the processes, I'm going to go into what SDLC is. We need to understand about the SDLC and what it entails, right? So the software development lifecycle is a process that developers do follow to create softwares, right? So these are processes like the planning process, the design process, the development process, the testing and the deployment process, right? They follow this process from the planning to the maintenance process. So this planning process is the process whereby these developers decide on what kind of software they are going to need. The design process is whereby these developers plan out their software on how it is going to look like, or the output it is going to look like. The development process. In this process, these developers are taking or map out the kind of software they're going to build, and they're going to design it in that development process. Coming into the testing process, these same developers or the team, they do test the software to make sure it is working perfectly before talking about deploying it to make it available to external users. So talking about how vulnerabilities sneak into this process from the planning phase to the maintenance phase. And I'm going to start from the planning phase. During the planning phase, as they are planning the project or as they are planning the application, they have to consider security from the start, and the design might miss important protective measures if they do not plan from the start, right? Now, going into the design phase, if the design phase is not carefully thought out, there are going to be a weak spot. What do I mean by weak spots? Weak spot means like flaws or loopholes. These loopholes are going to be the gateway for attackers to come in and exploit the application. So attackers can be able to gain advantage or get advantage of that weak spot to take control of the application. Coming into the development process, how the vulnerabilities tend to sneak into this process through the development phase. Developers might make mistake while coding. Yes, it is a normal thing for developers to make mistake, right? So through human error, an attacker can be able to exploit the system or gain complete control over the computer, right? So the attackers are not going after that system itself. So they are making sure that they find this aspect or they find this section that has a very bad code. They're going to take advantage of that application or try to gain access to that resource in the application. Talking about testing phase, these developers that do this testing, they don't test every functionalities. They don't test every aspect in that application. The attackers can be able to look out for the places that these developers did not test. So if this attacker are able to find these places that the developer missed, they're going to take advantage of it and exploit that application. The deployment phase, if the software is not properly secured during deployment, attackers can take advantage of the weak spots. Like I said, the weak spots are the flaws or the vulnerability. If the developer is not able to properly secure that application during deployment, the attacker can be able to take advantage of that weak spot. Talking about maintenance, if that software is being updated, if the software is being, let's say, maintained through that process, attackers can be able to, find a way to exploit a vulnerability in the application. Now, during this maintenance, they can either do something we call man in the middle. Man in the middle, it is a kind of an attack that allows the attacker to be able to sniff the application communication. So the attackers can be able to be in the middle of the application and the server, and they can be able to, sniff communication coming out from the server to the client. With this process, the attacker can be able to, gain access to the application, or even gain or get confidential information from that application during the maintenance phase.
Cyber Fortress, I must commend you for putting out such wonderful explanation. From everything you've been able to explain so far with regards to software development process, I'm still curious, from your explanation, it means that the developers and the company that wants that particular software, they've tried so hard to mitigate these loopholes, but at the end of the day, there is still a flaw. How come these flaws are not seen during the review and the testing phase of this software development cycle?
So now we have to understand how these kind of things happen, right? How these vulnerabilities get to sneak into this application during the code review. Code review is just like you studying that application, the application source code. You taking a look at the code to see or to understand whatever is going on in the code, right? What causes these vulnerabilities to sneak in between the application? During code review, most of these developers look into small details like naming and formatting, right? They only focus on formatting of that code. They don't focus on the big pictures like logic errors or performance issues, right? Like how is vulnerability going to get into this program? Or how is this program going to attract vulnerabilities? But if these developers are able to look into the logic errors, the performance issues of this application, they can be able to mitigate these vulnerabilities from coming into the application. We have lack of security focus. These developers are not focusing in security. Most of these developers are not studying about that security aspect of the application. They are just building the application, but they're not looking at what is going to happen if this application is being deployed. They're not looking at what is the attacker going to do in this process, or what is the attacker going to do in this functionality. So they have to look at that security process, right? The other thing they miss is also speed over quality. They tend to rush the application instead of giving themselves time to study the application and understand the security posture of it. They need to take some time to read about the application. They need to take some time to focus on that application functionality before they tend to deploy it or make it available to the public. We have miscommunication. Most of these developers need to learn to, communicate and collaborate with the security team in order to solve common security issues. Before that application is being deployed, the developer needs to make sure there is enough security standard in the application. If security is not well implemented in the application, attackers can be able to take advantage of it.
Thank you for that elaborate explanation. During your explanation, something caught my interest and I kind of penned it down. And you said during this software development phase, developers actually prefer speed over quality. Do you mind giving us a more detailed oversight? Because I would like to know, how would an organization request the services of a developer and instruct them on what to do and how to go about it, especially putting security at the forefront of what they are requesting for? How then do you end up, the developers going with speed over quality of the software they are developing for their clients? And do you mean to tell us that most developers are not qualified?
Okay, great. I'm going to give a brief insight about this speed over quality, right? Now, when it comes to development, the developer should not rush the application just to release the application very fast or very quick. When the developer is pressured to release the application so quick, he or she can be able to skip important security check, right? So that developer needs to, take his or her time to study the application to make sure everything is well placed, to make sure security is well implemented. Rushing speed over quality is going to make you to miss some important updates or to miss some important checks in the application. So you have to make sure you are focusing in getting the value of the application and not releasing the application. So like we spoke about the planning phase, we spoke about the deployment phase, we spoke about the other phases in this SDLC. When it comes to the planning phase, you need to make sure you plan with the security team that yes, we need to add the security mechanism in this process or in this functionality of the application, right? So this is the process whereby you need to make sure you carry out an extensive planning with the security team. So from here, you're going to know if you can be able to find a way to implement a better security. So if you don't plan with that security team, you are going to rush the process of you building the application. Your own destination is to release or to deploy the application without performing a security check. But in that planning phase, you're going to have this mindset that yes, I need to talk to this security team to, plan a better way of creating this application or plan a better way of securing this application from cyber attacks or threat actors. And when it comes to speed over quality, the developer needs to make sure they calm down and build the application, or they calm down and study that application to make sure there's no way an attacker can be able to inject any code, or that the attacker can be able to get into the application and take control over it. They need to make sure that application is well built and well secured from cyber attacks or threat actors.
For each answers that you give us begets questions. How can a web developer who is not trained in the field of penetration testing or ethical hacking be able to spot vulnerabilities in the code he or she is writing or developing?
So if you are a web developer and you want to know if this application can be vulnerable to this sort of vulnerability, what the developer have to do is whenever you're writing code, the code is written in some kind of English form. So if you're writing the code, you're understanding what you're writing. As a coder, like me or like you or like anyone, he or she needs to understand that code he or she is writing. But if he or she is able to understand that code, he or she can be able to find a way to implement a better security there. Let me come to input validation. So whenever I want to enter my phone number in an application, and instead of me typing a number, I'm typing a text. That application only accepts numbers and not text, right? If as a developer, I can be able to know that this place or this section, this application could lead to exploitation if the attacker is able to put in a text without verifying that the attacker is putting in a text. So this developer needs to know that this section or this input should only accept numbers, not text. So if that application is able to accept text, I can be able to run other attacks in the application, like XSS or open redirects. This thing can make the application to be vulnerable to XSS. Yes, XSS. Because if I'm able to type in a text, right, I can be able to take control of the application just by getting XSS. So that developer is going to know that this input should only accept numbers and not text. So you're talking about developers, how developers can be able to know that this place or this section should be vulnerable or not vulnerable, just by understanding what you're writing. If the developer is able to understand his or her code, they can be able to implement a better security measure in it.
Thank you, Cyber Fortress, for this wonderful answer. You made mention about input validation. As a cybersecurity expert, you are able to understand that improper input validation will lead to SSS or any type of vulnerability, right?
Yes, right.
So now my question is, what about a web developer who is not vast or equipped with this knowledge that you've been trained to possess over time? How will a web developer who, for the love of writing codes, develop this code or this web application without even knowing that the input validation, the input parameters can be easily bypassed to get different vulnerabilities in the code he has already written? What will be the best advice for that web developer who has happened to fall into this kind of situation and then seen his or her code being exploited by malicious hacker within few seconds of uploading the application online?
All right. So, as a developer, before you think about writing secure code, you're going to study about what kind of vulnerabilities exist in this application or in a web application, right? You need to read about XSS. Now, I want to prevent or I want to implement a better security in my application. I need to study about XSS, how it works, and how attackers can be able to take advantage of XSS in your application. Without the developer being able to study about that particular vulnerability, he or she cannot be able to prevent it. I'm not saying you need to learn how to carry out an assessment of XSS, but you just need to understand what XSS is and now these attackers exploit it. Now, talking about excesses mainly done inside the user input, right? Attackers, when they go into the application, they look for input feeds or they look for forms where they can be able to inject malicious code. Now, think of it as a developer. If this attacker is able to inject or write this code, is it going to execute in the application? You need to find a way to think out of the box. Not only the attackers think out of the box, even the developers need to learn to think out of the box, right? They need to study these vulnerabilities, XSAs, open redirect, SQL injection, and so on. So if they're able to understand XSAs, they can be able to learn how to prevent it. So for you to learn how to prevent that attacker from injecting or from exploiting your application, you need to understand how that particular vulnerability is being carried out by that attacker. Right? Now, we know that XSS is simply a web application vulnerability, and it is a client-side vulnerability that allows these hackers to inject malicious code into your website. If the attackers are able to inject this code into your application, they can be able to steal data from your application. This data can be cookies, session, login data, and so on. If these attackers are able to get your session cookie, right, they can be able to log into your account without your username and your password. Right, that session cookie is everything. Is your account login and so on. And if the attacker is able to get that session cookie, they don't need your username and your password. What you're going to be thinking as a developer is, how am I going to protect these inputs from attackers? You just need to study how these attackers are able to carry out their operation, how they're able to carry out these cyber attacks against the application. When you learn about these excesses, then from there you can be able to have a better understanding on how to prevent it or how to protect it.
You see, How Safe Is Our CyberSpace is that podcast that redefines and brings to life these tactics that these malicious cyber threat actors uses to exploit us on daily basis. And I'm happy that Cyber Fortress have been able to take us from the software development lifecycle, how web developers go through this process to develop a web application, and then how attackers or how vulnerabilities find their way into these web applications. And the beauty of it is that Cyber Fortress keeps on saying one thing: SSS. SSS is one vulnerability that is very common, but sometimes is difficult to patch because of different payloads that these cyber threat actors generate on daily basis to bypass our firewall applications, our WAF detectors, So how do bug bounty program help in mitigating this whole process, especially to the organizations that put out their web applications for good cyber actors and bug bounty hunters to help them find vulnerabilities? How do bug bounty program itself help in finding and mitigating these security flaws that the developers have been unable to detect while developing that application?
Bug bounty program is the deal offered by companies to reward you as a hacker for finding vulnerabilities or flaws in the application, network, or systems. This is what bug bounty program is. These programs can be like Twitter, Google, Tesla, or so on. Right? These programs come in and invite hackers to find flaws in the application, not just the application, but their system. How do this bug bounty program help? By letting outside hackers to find these security flaws. When it comes to bug bounty program, we know that the companies offers reward for we hackers to discover vulnerabilities in the application, right? So if bug bounty program is being implemented in SDLC or Software Development LifeCycle, right? Bug bounty hunters are going to be useful, or it can be of help in finding these security vulnerabilities which the internal team missed. These developers have or work with internal teams, right? Most of these internal teams are going to miss some certain security flaws in the application during maybe the testing phase or the deployment phase. When you bring in a bug bounty hunter, that bug bounty hunter is going to run a lot of enumeration on the application to find that flaw that security team missed. This is why bug bounty program is very important. Bug bounty program acts as extra layer of defense. We have the developer, we have the security team, and we also have the internal team. These internal teams are not enough to prevent these security flaws. which is why we have something we call bug bounty programs or bug bounty. Now, bug bounty comes into play in this particular aspect. So whenever you want to test your application, whenever you want to perform vulnerability scanning in your application, now you can just put your application out there. There are platforms like HackerOne. HackerOne is a platform that allows these companies to put the application on. And if these hackers are able to come into the application, they can be able to, start hacking into the application to find flaws or vulnerabilities, right? These hackers are given the permission, they're given the authorization to, break into this application, find flaws and report it. In bug bounty program, when you find the flaw, you're going to write a report to the company that you found this particular flaw. Let's use excesses as an example. And a hacker is able to find excesses. He or she is going to write a comprehensive report or a very good report of how she found the vulnerability or how he found the vulnerability. It's going to put the impact. It's going to write the step to reproduce. Now, this step to reproduce is the process that the hacker is able to follow to find this vulnerability, so that that company can be able to reproduce that same step to also find that same vulnerability and fix it. Now, can you see? Bug bounty is very important for the software development lifecycle or to these companies out there. These companies out there runs a lot of applications. They runs a lot of programs and so on. They have network out there. They need to invite these hackers to, legally break into the application to find vulnerabilities. Without these hackers breaking or penetrating into the application to find vulnerabilities, these companies are not going to know that there might be or there will be a security flaw in that application.
That's a very nice answer, and I must really confess you've been able to explain, explicitly what bug bounty hunting is, who a bug bounty hunter is, and how these bug bounty hunting programs help to mitigate all these vulnerabilities found in web applications. So now, going to one of the main points of today, I would like to ask you, Cyber Fortress, do you mind discussing with us in, let me say, 3 to 4 minutes, your best ethical hacking methodology when it comes to spotting and discovering SSS vulnerability?
All right, great. So I'm going to discuss the process I do follow in order to find excesses. The first process is the approach, right? This is when I am on my target. And also this is the process whereby I am interacting with my target, right? After this process, I am going into identification. This identification process is when I am able to find the functionality of the application. Like I need to know what kind of functionality exists in the application, like sign up, login, forgotten password, and so on, right? Now, where can I test for excesses? I can look out for excesses in input field. So I need to look for input field in the application or that website in order to test for excesses. But before you start going into exploiting a vulnerability in an application, you need to first of all study the application. You need to understand the application, how it is built. Like if I am able to know that this input field or this input parameter is vulnerable to excesses, I can be able to start testing for it or start exploiting it. But before I start putting in my payload or start injecting malicious code, I need to understand how that application is able to handle my data. Is it processing my data from the server side or is it processing my data from the client side? With these two things, I can be able to know where and how to test for my vulnerability or my XSS payload, right? If I get into the application and after the approach and after the identification process, I try to observe that functionality. If I go into the input field, I need to know how this input field is working, how my data has been processed, right? I need to test it like a normal user. I don't just go into that functionality and start exploiting it like a hacker. Like I need to interact with the application like I'm a normal user instead of me going after exploiting it. So when I'm done with observing it, because I know how this functionality works, with that idea or with that knowledge that I understood about that functionality, then I can be able to use it to exploit or to take advantage of it. In this case, if that application has a search field or an input field, right? If I type in normal data, does my data get reflected back to me on the page? Let's say I type hello Dio. Am I going to get hello Dio back on the page? I'm able to get hello dial back on the page, then it means that I should go further to test for excesses. Now, what kind of excesses am I going to test for? Right? Before I go into it, I'm going to discuss about the three main type of excesses. We have the reflected, we have the stored, and we have the DOM, which means document object model. The reflected excesses means it's a vulnerability that is only that only affects the user, the single user, or the client user. This reflected vulnerability does not affect everyone, right? If I am able to find a reflected vulnerability, it only affects me on that same browser, on that same session. But if you find a stored XSS, it affects everybody who visits that same resource. Let's say I put in a stored XSS into this application. If a new user visits that same resource, he or she is going to get affected. And I can be able to do anything from there, like stealing data, capturing session cookies, and so on. This DOM XSS is not commonly exploited. So the only vulnerabilities that attackers do commonly exploit is the reflected and the stored XSS. Talking about the severity, this reflected XSS has lower impact than the stored XSS. The stored XSS has higher impact. This can be high, this can be medium, but the reflected has a low impact. This stored is way too critical than the reflected. This store can affect any user that visits the application, but this reflected is only affecting you. Now, doing bug bounty hunting, if I find a reflected XSS and I report it, that company might close it as informative, as something that is not critical, right? Now, they're going to tell me that this vulnerability does not have a security effect on their company or their organization. But if I find stored XSS, they're going to accept it as critical because it is affecting all other users on the application, right? This is the process I do follow whenever I'm looking at for XSS. Everybody have different process. Everybody have different approach, right? Now, my own approach might be different from other security researchers out there. Okay, so like I said, you need to study the application, learn how that application works, right? After studying about the application, then you need to observe those functionality. After you have observed them, then you try to exploit it.
Cyber Fortress, you've opened my eyes and the eyes of our audience out there. I must really say your methodology is something that I think if I'm to rate it with the way you explained it, I will give it over 65% to 70% in terms of getting me bugs, because the way you were able to analyze your target, the way you were able to take time to study your target, and you were hinting on the fact that we should understand the framework of the application. So I would like to ask you, what type of framework do you think is more susceptible to SSS attack? Is it an application built on Python Django? Or is it an application built using Laravel? Or is it an application built using Ruby?
Okay, so talking about these frameworks, right? All frameworks can be vulnerable to XSS depending on how that developer is able to write the code or build the application. Talking about XSS, the framework that you can be able to spot XSS with is JavaScript. And we know that all application uses JavaScript. All application work with JavaScript as the client-side language. If I find out that this application uses JavaScript and I found an input field, I can be able to carry out XSS. You note, not all developers are very good at implementing a better security posture in the application. Some of these developers can miss some certain things in the application. And if that developer is able to use outdated framework, that attacker can be able to, find vulnerabilities like XSS in the application. Come to think of jQuery. jQuery is a JavaScript framework, and they have vulnerable or outdated plugins or jQuery libraries out there. These attackers can be able to perform what we call vulnerability assessment. If they are able to find the version of this jQuery framework, they can be able to perform a vulnerability assessment on that framework and find out the flaw involved in it. And if they found out that the flaw here is XSS, they can be able to take advantage of it just by looking out for vulnerabilities that exist out there. And they can use that exploit on that framework to gain access to the application.
So in other words, all frameworks are vulnerable to SSS, attack. It depends on the payload and the level of security that the developer has put in place in order to protect them, right?
Yes. All frameworks are vulnerable to what? XSS. They are vulnerable to any vulnerabilities out there, right? So, like I said, if the developer is not able to implement a better security system, a better security mechanism in the application, that attacker can be able to take advantage of it and break into the application. The attacker can be able to, exploit it. When you tend to look out for the tech stack of this application and you find the framework, most of this framework have what we call versions. If you're able to find these versions, you can be able to perform a vulnerability assessment on that framework version. I can go online and look out for jQuery version 6.7. If I find a vulnerability for jQuery version 6.7, I can be able to use that exploit for that particular version against the application and take advantage of it.
Cyber Fortress, enough of this explanation, You've really, really made me so anxious, and I think we can't wait no more. But before we go into this next phase, where Cyber Fortress will display a live hands-on demonstration of how this SSS vulnerability is exploited, I would like to put out this disclaimer to our viewers out there. Whatever hands-on simulation attack our guest is performing, please don't try this in an uncontrolled environment. The purpose of this podcast is to make you aware of these tactics that these cyber threat actors use to manipulate us. We make sure that we display the live demonstration for you to see, but our guest performs this live simulation attack in their own controlled environment. They are liable for what they do, and you are liable for what you do with the information you get from here. Whatever we do here is strictly for educational purposes, and so we expect you to perform this simulation attack in a controlled environment. Please, this is strictly for educational purposes. So Cyber Fortress, could you walk us through a live demonstration of how SSS vulnerability is exploited?
So this is Kali Linux, a Debian operating system for pen testing. And before you go after attacking your target application, make sure you get authorization. Make sure you get permission from that company. Or whatever I am demonstrating right here is I am using a vulnerable web application called BWAP. BWAP allows me to practice or to demonstrate this XSS vulnerability without attacking a real target. With this BWAP application, I can be able to test these vulnerabilities in my controlled environment. I have permission to test for these vulnerabilities. I have authorization to look out for them. Okay. This is the vulnerable web application. When you set it up on your Kali environment, you're going to create a new user account and login.
Okay.
So right now, we're going to be demonstrating XSS, and I'm going to select XSS right here.
So this app is just developed strictly for learning purposes.
Yes.
So what we are witnessing is a real-life simulation attack displaying how XSS vulnerability is being exploited on our web application. This attack is done live by Cyber Fortress, and like we always say, please don't try this in an uncontrolled environment.
All right, so this is the application, right? Now, when you visit the application, you need to identify every functionality in the application. So right now, we found an input field. This input field is telling us to enter our first name and our last name. Before you start exploiting it, you need to first of all observe it or interact with it like a normal user. So I'm going to use a random name, test, and the last name, paste. When I hit enter or go, I'm going to get welcome, test. I see it. Yes. The two values I entered in the input, the first name and the last name, got displayed on the web application. With this, I can be able to take advantage of it. Of me putting in test, I'm going to type my own malicious code to find or to get accesses. Okay.
So malicious threat actors, whenever they see such form fields in a web application, it's like a gateway pass for them to test, for XSS vulnerabilities, right?
Yes. So if an attacker is able to find this form field, they are not going to skip it. They are going to test it. They want to know how this form field works or if it is properly validated. So they're going to start testing for different client-side or server-side vulnerabilities like XSAs and so on, or SQL injection, right?
Okay.
So what I'm going to do is, when these attackers are able to know that this functionality is able to reflect my text back to the page, they're going to look out for testing for XSS. Okay, so instead of me putting my first name as test, I'm going to put in a basic XSS payload. We have this basic XSS payload called script alert 1. Then you're going to close it with that same script, right? I'm going to explain what this payload is doing. If I type in this payload, basically this payload is going to open or pop up an alert box. Inside that alert box, it is going to show 1, or it is going to put in the letter 1 inside the alert box. Okay, when you run this script and you get a pop-up alert or alert message, then it means that there might be a potential XSS vulnerability. Okay, let us test it out to confirm if this input field is properly validated or not. I'm going to put in the first name as script alert 1, and I'm going to put in the last name as normal letter. Okay, it's go. Now, can you see it? We have...
Yes, I can see a pop-up box on your screen.
We have a pop-up box right here showing the number 1. This tells us that this application is what vulnerable to what XSS. Okay, but this is what you need to know. Not all applications are vulnerable to this form of payload. Right? Whenever you make use of this payload and it doesn't work, try to use other payload. There are a lot of payloads out there that can allow you to look out for or to test for XSS vulnerability. But don't just focus on one payload. You have to explore other payloads. I'm not going to dive into firewalls because this is not what we're going to talk about. But firewalls is one of the major things that you need to know about in web application. You need to understand about firewalls, right? If that application is making use of firewalls, that firewall can be what is preventing that application from executing your payload. So firewall is one of the major things that you need to learn in web application, right? Now we got the pop-up box, right? What are you going to do next? As an ethical hacker or a bug bounty hunter, they're going to write a report to the company that you found this vulnerability and they're going to fix it. Let me talk about the impact of this XSS. The impact of XSS is session hijacking. The attacker can be able to steal your user session. The same process you use to get XSS is also the same process you use to get the cookie. If me as a threat actor is able to capture a user session token or a cookie, I can be able to log in to the application without that user's email and password.
So you mean to tell me that this same process that got you that pop-up box on the screen is going to also extract the section cookie from that particular web browser on the client side, right?
Yes, perfect. Yes. This session cookie is what identifies me that as the user, I'm logged into the application. If I find a XSS vulnerability, I want to take advantage of that vulnerability to escalate it by stealing user's session cookie. I'm going to demonstrate it real quick. So I'm going to type the same payload. Inside this payload, I'm going to take off alert 1 and I'm going to put alert document.cookie. This function is going to display the session cookie or the session token of this application because I am logged in. With that session token, that belongs to that user or to that logged in user. If I am able to get it, I can be able to log in as that user without the password or the username. Let us put it into action. The last name as normal random text. Now I'm going to click on go. Now if you take a look at this pop-up, you're going to see PHP session ID. And this ID here is the cookie or the session token. If I copy this cookie and open it in a different application, I can be able to log in as this user without the username and the password.
So what you just performed for us is you crafted, a malicious payload. You saw an input or form field in a web application. That crafted malicious payload was what, inserted into the input field, and you were able to extract the section cookie of that particular user who is actually logged in to that web application at that point in time. That is, he just stole his actual identity. What connects him, what links his identity to the web application API? You actually stole the cookie. That's what you did, right?
Yes, perfect. So if the attacker is able to have just this cookie, this session ID, the attacker does not need that user's email and password or login details.
Cyber Fortress, I'm really impressed, with this top-notch skill you've acquired over the time. What I would like to ask you, from what you did, what are the immediate long-term consequences of this SSS vulnerability attack?
All right, talking about the immediate or the long-term consequences. If to say XSS varies in their different type, right? Like I mentioned, we have the three type of XSS. Okay, if I'm talking about reflected, these companies are not going to get this kind of let's say this kind of fear to fix it, because me as the hacker, I cannot be able to cause harm to that company's infrastructure. So talking about this long-term consequences, we have stored accesses. Stored accesses can cause a lot of damages. It can cause a lot of critical issues. This stored accesses is stored in the database, right? Any payload you impute in this impute field, it is stored in the database. And from that database, anybody that visits that application, even the admin of that organization, can also be affected. And that attacker can be able to, steal that session cookie of that admin. So talking about stored accesses, there's going to be a long-term consequences if stored accesses is being found in the application. Okay, where do you look at for stored accesses? You can spot stored accesses in post method, or let's say the application is trying to insert a data into the database, right? So if that application is trying to insert a data into the database, I can be able to put in my payload, and my payload is going to get inserted, right? Now, if a new user or if another user is able to visit that application, he or she is going to get affected. Now, multiple users are going to get affected, and the company are going to lose reputation. So they're going to lose a lot of things, a lot of users' data and so on. So there's a long-term consequence for stored accesses and not reflected.
So from these three types of SSS attack, the stored SSS is the one we have to look out for, which, from your words, there is a long-term consequence to the destruction that particular vulnerability can do to a web application, right?
Yes. Stored accesses is more effective than reflected. Very, very effective. If I find stored accesses, I'm going to be, like me as a bug bounty hunter, I'm going to be very, very happy, because the bounty I am going to get is going to be very high, because these stored accesses affect every user. It can also affect the admin. It can affect the developer of that application. It can affect anybody. So if that company or that organization is trying to fix these stored accesses, they're going to go through a lot of processes to fix it. So stored accesses is more critical than reflected. It is also very critical than DOM, which is the document object model accesses.
In as much as you've been able to tell us that as a bug bounty hunter, you tend to make a whole lot of money when you're able to discover this vulnerability on a web app that you're testing. I know you want to make a whole lot of money. What are the best security practices, with your experience, you would recommend, to companies, to different organizations, to protect themselves against this vulnerability? And in particular, in terms of integrating continuous monitoring and automated testing, and then also employee training in the process, what are the best security practices you would recommend to these organizations and companies out there?
All right. This question brings us back to the SDLC, the Software Development LifeCycle, right? Yeah. When during the planning phase, or during the phase whereby the company or the organization are planning to build the application, they need to make sure there are certain security control in place. Okay, they should not just build the application and deploy it. Before deploying, or before building, or before development, they need to plan about the security strength of the application before deploying it. Talking about the security implementation, or how they should implement their security in the application, they need to know, let's say the application is trying to build an e-commerce website, right? They need to find a way to make sure that, can this attacker be able to buy these products without paying for it, right? Then they need to think, they need to have this mindset of this attacker on how they are able to take advantage of these features, right? Let's say I visit an e-commerce application that allows me to buy products. If I see that this product has a price of $45, can I buy the product with the price of $10? These developers of this organization need to have this mindset that can this attacker be able to, manipulate the price to buy it as low as $10 instead of $45? This is called what? A business logic flaw or a business logic vulnerability. These developers of this organization need to look at that aspect. Okay, they need to think about it before deployment phase, which is why we spoke about the SDLC, the Software Development LifeCycle. They need to follow it, right? They need to what? Focus on the quality and not speed. They need to what? Make sure there is better security implementation in the application before deployment. They need to plan with the security teams and not just the internal teams. So we can also help them to find this vulnerability by them hosting their program online. So if they're hosting their program online, it means that they are giving us permission to find these vulnerabilities and report it back to them. And with this kind of action, right, they're going to know where and how this application can be exploited by the threat actors, right? So this is the advice I can give to this organization out there that are trying to, find a way to implement a better security for the application.
It's truly been a wonderful time spent with Cyber Fortress. Cyber Fortress have been able to unload his wealth of knowledge to us, and what's left is for us to take the information he spilled out to us on this episode of How Safe Is Our CyberSpace, take it in handy and make good use of it in terms of keeping our web application safe. Because today's episode, is specifically talking to our web developers. I think you have a lot to learn from today's episode. You need to take your time, ask yourself this question: are you actually following the software lifecycle development process? Are you following the actual procedure in developing your web applications, putting security at the forefront of everything you do? To our first-time viewers, I want you to know that this channel, this podcast will continue to bring you the best, the most experienced cyber defender who has proven themselves over time to be good cyber actors, to come and educate us on how to stay protected on our cyberspace. On this note, I thank you all for joining us, and I thank you, Cyberforce, for sharing your wonderful time with us. We hope someday we will see you in the future to discuss more on the issues bothering our cyberspace. Have a wonderful night, Cyberforce.
All right. Good night.